So in this first lecture, we will be learning about the concept of loads. So there are two different possibilities of an axial loading. So the first possibility looks something like this thing. This is the cylindrical bar, and the load is subjected to something like this. Of load P is subjected to this cylindrical rod. Now we call this load as a tensile loading. Tensile loading. Now the other possibility of the loading looks something like this thing. Yeah. So the nature of load is this thing. So this type of load is called compressive load. Compressive load. So you should note that equal and opposite force acting perpendicular or normal to the cross-sectional area constitute the axial loading. So this load is perpendicular to this cross-sectional, that is, it makes 90 degree to the cross section. It is 90 degree. It is normal to the cylindrical cross section. Now let's focus about the Sine convention. So generally we take positive Sine convention for tensile loading, and for compressive loading we take negative Sine convention. Now let's talk about that how we are going to calculate the axial loading for any section. So suppose there is a rectangular cross section. Now this rectangular cross section is subjected to the loading of 100 kilonewton, that is the tensile loading of the 100 kilonewton from both sides. So now we want to know how much load is subjected to this cross section. So the main concept for calculating the load for any cross section is that axial load at any section is equal to the summation of the load on either side you should remember the either side. This is the main concept. Either side means like we have to divide this rectangular cross section in two parts. So this is the right hand part, right hand side part, and this is the left hand side part. So for calculating the axial load, we will either take the right hand side part, or we can consider we can either take the left hand side part. So it's up to you. Either you take a right hand side part, or either you take left hand side part. So for this case, I'm going to take left hand side part. So you can see at the left hand side part, that is this part, only 100 kilonewton force is subjected, load is subjected. So the load acting at this cross section, that the axial load is equal to 100 kilonewton for this cross section, because only 100 kilonewton force is present on left hand side. Now we can cross check whether we are correct or not. So we can also, for cross checking, we can take the right hand side part. So we can see that right hand side part, the load is 100 kilonewton, which is balanced, totally balanced. Now let's see with the help of another good example. Let me first clear this thing up. Okay, so let's take another specimen. Let me draw it. Okay, cool. So suppose our specimen looks something like this thing. Okay, so this is our specimen, and this is the x1 cross section, and this is the x2 cross section, and this thing is x3 cross section. Now let me plot the load, that how much load it is being subjected to each part. So this part is subjected to 75 kilonewton axial loading. Here it is acting 45 kilonewton axial loading. At this part it is acting 150 kilonewton axial loading, and at this part it is acting 30 kilonewton axial loading. So now we want to calculate the axial load which is being acting at the cross section x1. So for at this cross section, how much load is acting? That is x1 cross section. So we have already talked that for calculating any type of axial load, we will take the summation of load on either side of the cross section. On either side of the cross section, that can be left hand side or it can be right hand side. So if you are going to take the left hand side part first of the x1 cross section, okay, so this is the left hand side part of the x1 cross section. This is the left hand side part of the x1 cross section. We will also verify for right hand side part. So for left hand side part, you can see that mistake, this is the right hand side part, this is the right hand side part. So for right hand side part of this x1 cross section, we are going to check x1 cross section axial loading. So px1, that is load on x1 cross section, is equal to from right hand side part, we can see that 150 kilonewton is incompressive in nature because it is pointing towards the cross section area. So we are going to take the sine convention, so we will write minus 150. Now the under load in right hand side cross section is the 45 kilonewton, which is pointed away from the cross section, which is the tensile loading. So as per sine convention, we are going to take plus 45 kilonewton. Now the under load is the 75 kilonewton, which is pointed away from the cross section of the x1 cross section. So it is also a tensile loading, so we are going to take the positive sine convention, that is plus 75. So after solving, we are going to get minus 30 kilonewton towards, if we have considered the right hand side cross section. Now if you want to calculate from left hand side cross section of the x1, so we can see that for left hand side cross section, it is only one force is acting, that is 30 kilonewton. So we will write which is compressive in nature, so we will write minus 30 kilonewton directly, that is from left hand side cross section. So we can see that right hand side and left hand side are totally balanced, so we can take either side. Now if we want to calculate the axial loading at the x2 cross section, for x2 cross section, now let's take the left hand side of the x2 cross section. Better option to remove this thing. Yeah, okay. Now for x2 cross section, first we are going to consider, okay, let's take the right hand side first, the right hand side part for x2 cross section. So you can see that the right hand side part of x2 cross section is subjected to the tensile loading of 45 kilonewton, so it will be plus 45, and it's also subjected to plus 75, that is away from the cross section, that is the load is away from the cross section, so we are going to write plus 75. So after summing up, we are going to get 120 kilonewton, which is obtained from considering right hand side cross section. Now similarly, in order to verify whether we are correct or not, we can also consider the left hand side cross sectional part, left hand side cross section of x2. This is left hand side. Um, so px2 is equal to, so from left hand side we can see that a compressive load of 30 kilonewton is acting, so we can write minus 30 kilonewton, and we can also see that tensile loading of 150 kilonewton force is also acting, so we can write plus 150. So after summing up, we are going to get plus 120 kilonewton, which is obtained from left hand side cross section. So we can see that they are totally balanced, either from right hand side or either from left hand side. Now let's calculate the axial loading for the x3 cross section. We are going to follow the same concept. Let's consider the right hand side cross section first of the x3 cross section. So for x3 cross section, we are going to get px3 is equal to plus 75 bits, because it is subjected to the tensile loading. So plus 75 kilonewton from right hand side. Now let's take the left hand side part in order to verify, cross verify. So this is the left hand side part of this x3 cross section. So so px3 is equal to, so from left hand side we can see first it compressive loading of 45 kilonewton is acting, so we are going to write minus 45, and a tensile loading of 150 kilonewton, which is away from the x3 cross section, so we are going to take it tensile loading and we'll give a positive sign, that is 1 plus 150 kilonewton, and also a minus 30 kilonewton, that is the compressive loading of a 30 kilonewton force is acting, so we are going to take minus 30. So after summing up, we are going to get 75 kilonewton from left hand side, so which is equal to the right hand side. So it is totally balanced. So the main takeaway from this lecture is that the axial load at a section is an algebraic sum of all longitudinal forces acting on either side of that particular section.